multiplying and dividing radical expressions. Our objective is to multiply and divide radical expressions, as well as rationalize denominators. Who uses this? Electricians can divide radical expressions to find how much current runs through an appliance. Let's look at multiplying square roots. So we have the square root of 3 times the square root of 6. We can put them under one radical sign together, so we have 3 times 6. So now we have the square root of 18. Once you have it together, you can now simplify it. So we want to pick two factors of 18 where one of them is a perfect square. So 9 and 2. 9 is a perfect square. When we take the square root of 9, we end up with 3. We can't do anything with the 2, so it stays underneath the square root symbol. So now let's try B. This is like saying 5 square roots of 3 times 5 square roots of 3. Well, 5 times 5 is 25. And then we have the square root of 3 times the square root of 3. So we have 3 times 3 underneath the square root symbol. So we have 25, and then we have the square root of 9. Well, the square root of 9 is 3. So we have 25 times 3, which is 75. Let's try another one. Let's look at C. So we have 2 times the square root of 8x times the square root of 4x. So now, let's look at combining what's underneath the square root. So we're going to keep this 2 outside. So then we have the square root of 8x times 4x, which means that we have 2 times the square root of 32x squared. Well, now we can start splitting things up. So we have 2 still outside, but our 32 can break up into 16 and 2. So we have 16 times 2 times x squared. The square root of 16 is 4. And we can't do anything with the square root of 2, so it's going to stay underneath. However, the square root of x squared is x. So when we simplify what's outside, we have 8x square root 2. Now let's look at using the distributive property. So we're going to distribute this square root of 2 to each value inside. So we're going to distribute it to the 5 and the square root of 12. So we have the square root of 2 times 5 plus the square root of 2 times the square root of 12. Well, the square root of 2 times 5 is 5 square roots of 2. And then we have 2 times 12, which is 24. So we have plus the square root of 24. We can simplify the square root of 24. So we can separate this into the square root of 4 times the square root of 6. We can't do anything with 5 square roots of 2, so we're just going to continue to rewrite that. And the square root of 4 is 2, and there's nothing we can do with the square root of 6. So, our end result. Take a moment and pause the video and try B on your own. When you return to the video, the answer will be revealed. So we distribute the square root of 3 to each term inside of our binomial here. So we have the square root of 3 times the square root of 3, which is the square root of 9, which also goes down to 3, because the square root of 9 is 3. And then we have minus the square root of 3 times the square root of 5, which ends up being the square root of 15, and we can't simplify the square root of 15 any further. So put them together and you have 3 minus the square root of 15. So now let's try multiplying sums and differences of radicals. So we're going to multiply the quantity 4 plus the square root of 5 times the quantity 3 minus the square root of 5. So when we do this, remember we distribute each term to each term in the second one. So we distribute the 4 to the 3 and the square root of 5, and we distribute the 5 to the 3 and the square root of 5. So we have 4 times 3, and then we have minus 4 times the square root of 5, and now we have our second term here. We're going to distribute that one across. So we have plus 5 times 3, and then minus the square root of 5 times the square root of 5. And now we can start to simplify. So we have 4 times 3, which is 12, minus 4 square roots of 5, and then we have plus, we're going to just rewrite this in a better order here. So we have 3 square roots of 5, means the same thing, and then minus the square root of 25. And now we're going to keep simplifying. So we have this 12 here. We can combine these two terms. So we have minus the square root of 5, and then the square root of 25 is 5, so minus 5. And then we can combine the 12 and the negative 5, and we have 7 minus the square root of 5. In this next one here, remember, it's this whole quantity to the second power. So it's like saying the square root of 7 minus 5, that quantity times that same quantity again. Using that hint, see if you can apply what we just learned to the left to b. When you return to the video, the answer will be revealed below. Alright, so we have our square root of 7 times the square root of 7, which simplifies to 7. And then we distribute the next part, so we have the square root of 7 times negative 5, and then the negative 5 times the square root of 7, and negative 5 times negative 5, which is plus 25. So we combine our like terms, and we end up with 7 minus 10 square roots of 7, plus 25, and then we combine our 7 and our 25, and we have 32 minus 10 square roots of 7. So now let's look at a quotient. A quotient with a square root in the denominator is not simplified. To simplify these expressions, multiply by a form of 1 to get a perfect square radicand in the denominator. This is called rationalizing the denominator. Let's take a look at that. So we have the square root of 7 over the square root of 2. In previous lessons, we were always able to take whatever the square root was on the bottom and it would give us a nice number because it was a perfect square. Well, this time the square root of 2 is not a perfect square, so we need to rationalize the denominator. So what we're going to do is we're going to multiply by a form of 1. The square root of 2 over the square root of 2 is equivalent to 1. And if you multiply the denominator by the same thing, so we have the square root of 2 times the square root of 2, that's going to simplify to 2, or if it helps, the square root of 4, which is 2. Because you have the square root of 7 times the square root of 2, which is the square root of 14, and then we have the square root of 4, which is 2. Let's take a moment and look at b. So we want to rationalize the denominator. So we're going to multiply the top and the bottom by what's on the bottom here. So we're going to go square root of 8n and the square root of 8n because this is a form of 1. So now let's multiply. We have the square root of 7 times the square root of 8n, which gives us the square root of 56n. And then the square root of 8n times the square root of 8n is simply 8n. We can, however, simplify the square root of 56n, because 56 breaks into 4 and 14. So we can take the square root of 4, which is 2. So we have 2 square roots of 14n on top, and then we have 8n on the bottom. We can simplify one step further by reducing the fraction here, 2 over 8. So we end up with the square root of 14n over 4n. Take a moment and pause the video and try C and D on your own. When you return to the video, the answer for both will be revealed. So we have the square root of 65 over 5, because when we multiply the square root of 5 to the top and bottom, we get rid of the square root in the bottom, and we can't simplify the square root of 65 any further. So now let's look at D. D was a little bit more work. So we multiplied both the numerator and the denominator by the square root of 12, and then we end up with the square root of 84a as their numerator, and then the square root of 12 times the square root of 12 gives us 12. We can split 84 up into 4 and 21, and the square root of 4 is 2. So we have 2 square roots of 21a over 12. We have one more step. We can simplify or reduce the fraction. So we divide both the top and the bottom by 2, and we end up with the square root of 21a over 6. And that concludes our video on multiplying and dividing radical expressions.